Hey, welcome to our channel. I'm Geetanjali, your math coach, and today we are going to learn Divisibility Rules Part 2. In this video, we will learn how we can determine the divisibility of given number by prime numbers using Vedic math methods. Let's learn to test divisibility without dividing. We will test divisibility by prime numbers. In our previous video, that is in part 1 of divisibility rules, we have already learned how we can find divisibility by numbers from 2 to 11. So let's start with prime numbers. So what are prime numbers? Prime numbers are the whole numbers greater than 1 which are divisible only by 1 and itself. A few numbers are written here, for example 2, 7, 13, 29, 31, 47, 97, etc. etc. So all these numbers, if you observe, are divisible only by 1 and itself. No other number can divide these numbers. You observe this number 2. This is only even number which is a prime number, and also this is the smallest prime number. Rest all the other prime numbers are odd numbers. So to understand the process of divisibility by prime numbers, you need to understand a few more things. One of them is osculation. So what is osculation? Osculation is the mathematical process of adding or subtracting the product of whole number, that is osculator, and the remainder of the number divided by 10 to or from the quotient of dividing a number by 10. When you read this definition, you may find it quite confusing, but it is not at all confusing. It is a very simple thing. I'll explain you with the help of example. Osculate 715 by osculator 4. So here this osculator is given, but what we need to find is remainder of the number divided by 10 and the quotient of dividing number by 10. So suppose when we divide 715 by 10, what do we get? So we are dividing it by 10. 10 sevens are 70. You subtract this will get cancelled. This is 1 and 5. 10 ones are 10, and here when you subtract you get 5, this get cancelled. So this 5 is your remainder. This is your remainder, and this is your quotient. This is your quotient. So as per the rules, what we have to do, we have to take this quotient separately. So quotient is 71, we have taken this, and this remainder 5 will be multiplied with osculator 4. So we get 5 fours are 20, and we are adding it. So when we add it here, it will be 71 plus 20. You will get 91 as answer. So you have osculated it once. If suppose you want to osculate it once again, the method will remain same. What you are going to do now, the number is 91. You divide it by 10. So 10 nines are 90. This is 1. This get cancelled. So now this is your remainder. This is your remainder, and this is your quotient. This is your quotient. So to repeat osculation process, you write 9 here. 1 multiplied with osculator 4, you get 4. You add this 4 to 9 and you get 13. So this is your final result after the osculation. So your answer is 13 after the osculation. But whenever you will do this osculation process, you don't need to do all these exercises, because when you divide a number by 10, if the unit place digit is 0, it is completely divisible by 10 and you don't get any remainder. But if it is any other digit other than 0, that number will be your remainder always. Like here it was 5, here it was 1. And the number just before the unit place digit, whatever number was there, was the quotient. Like here in this case it was 71, and in this case it was 9. So you can simply take, if 715 is the number, you can take 71 here. You take this 5 here, multiply this with osculator, get the number, add it to get the result. Now again, if you want to osculate, same process, you write this 9 here, this is your remainder right here, multiply with the osculator and add it. So your answer is 13. But I'm going to explain you one more method which is much more simple than this method, and when I will solve questions for divisibility by prime numbers, I will I will use this method. So suppose the number is 715 and you have to oscillate it by 4. Purposely I have left a space between these digits because I need to use this space. So when you have to oscillate this number 715, first you multiply this 5 unit place digit by the oscillator. Whatever result comes, like here it is 20, add this result to the next digit. Add this result to the next digit. You have to add this to next digit, so you get 21. Now since you have got a 2-digit number, you need to oscillate this number once again. So this is your unit place digit. You multiply this one with the oscillator, you get 4. Now you add this number to this number first. When you add this number here, you get 4 plus 2, 6, and then add this to 7. Again you will add this to 7, you will get 13 as your result. So this is your final result of oscillation. You can match this. This is same. Whenever I will use process of oscillation for divisibility rule, I will follow this method. So please try to understand how we will go about this method. I will explain you by one more example. Oscillate 294 by oscillator minus 2. Here I have taken a negative oscillator. Oscillator may be positive, it may be negative as well. Whenever you have to oscillate, you need to consider sign always. Don't ever forget to consider the sign. So when we have to oscillate 294, first we will write 294. So 29 and your remainder will be 4. You multiply this with oscillator minus 2, your answer is minus 8. Now you will have to add this minus 8 to 29. Now when you add minus 8 here, actually you will subtract 8 and your answer is 21. Now if you want to oscillate this once again, the same process. 2 you will write here, 1 you will take here, multiply with the oscillator, you get minus 2 here. So minus 2 you will write here and your final result is 0. Now by the shortcut method, you will write this number 294 here. First you multiply this 4 by the oscillator. So 4 multiplied with minus 2 will give you minus 8. Now this minus 8 will be added to 9. When you add this to 9, you get 1 because 9 minus 8 will give you 1. Now this is single digit number. Simply multiply this 1 with the oscillator, which is minus 2 here, and your answer is minus 2. Now this number will be added to the next number, which is 2, and your answer is 0. You can match this 0 and this 0. So this is the way how you follow the oscillation process. Now oscillator is the number which is multiplied with the remainder of number divided by 10. To test divisibility by prime number, we need to find oscillator of divisor. And to find oscillator, the important condition is that the divisor should end in 1 or 9. For example, 7, 13, 29, 31, etc. are prime numbers. But you can see all the prime numbers doesn't end in 1 or 9. For example, this 29 is fine, it ends in 9. This is fine, this ends in 1. This is fine, this ends in 9. But what about the other numbers? If you have to find their oscillators, how will you go about it? You can always multiply by a suitable number so that you get a number which ends in 1 or 9. For example, 47 if I take, I will multiply this by 3. So 3 sevens are 21, 3 fours are 12, plus 2 is 14. So now the number is 141, which ends in 1. So you will follow the method to find oscillator of this number, and the same oscillator will be the oscillator of 47. For example, if you have to find oscillator of 113, you can multiply this by 3 again. So you get 339. This number ends in 9. Now you can find oscillator, and whatever oscillator you get from here will be oscillator for 113. Find oscillator of divisor ends in 9. In this case, you get a positive oscillator. So how do we get it? Increase the digits before 9 by 1 and take that as oscillator. For example, oscillator of 19. When we have to find oscillator of 19, we will take digit before 9, which is 1. We increase it by 1, So we get 2, and 2 is our oscillator in this case. One more example, oscillator of 139. See, before 9 we get 13, we add 1 to this, so we got 14. So 14 is oscillator in this case. Now you have to find oscillator of 13. It doesn't end in 9. So of course we can get a number which ends in 9. We multiply it by 3, we get 39. So if as per the rules, if I try to find out oscillator for this, it is going to be 4, because digit before 9 is 3 and add 1 to it, that is 4. That is going to be oscillator for 13. Now oscillator of 7, this also doesn't end in 9. We can always multiply it by 7 to get 49. So before 9 there is 4. You add 1 to this 4. You get 5. 5 is oscillator of 7. So this way you can find oscillator for the number which ends in 9. Now what about the oscillator of divisor which ends in 1? In this case, first of all, the oscillators are negative. Just drop 1 and take the negative of remaining number as oscillator. For example, you have to find oscillator of 81. So you will drop this 1 and the leftover number is 8. You take its negative and that is going to be your oscillator. We have already solved a question in that we had -2 as our oscillator. Now let's take one more example. Oscillator of 131. This ends in 1. So before 1 there is 13. Negative of 13 is your oscillator. Now oscillator of 7. One thing we have already done, we had multiplied by 7 to get 49. We can multiply it by 3 to get 21. In this case, your oscillator is going to be -2. So oscillator for 7, it may be -2 or it may be 5, but you need to follow the process. Depends on how you have found out the oscillator. So what is the process? So test divisibility by prime numbers. Now we will observe the steps, how we can go about it. When divisor ends in 9, in this case you get a positive oscillator. So I will explain you with the help of example. All these steps we will do one by one. Let's see what we will do about this. First step, compute oscillator of divisor. So here divisor in 19, we have already done. Its oscillator is going to be 2. Why? Because before 9 there is 1. You add 1 to this and 2 is going to be your oscillator. Now we have to start oscillation process, which I have explained you already, but let's do it step by step. So in the first step, we have to multiply last digit of the dividend by oscillator and add the product to the digit prior to the last digit and write the sum below the previous digit. So I will write the digits. I'll keep some space between them so that I can do the process with some ease. 3971 was my number. Now first, as per the first step, 1 will be multiplied with oscillator 2, so we get 2. So this 2 will be added to this 7 and we get 9 here. Now as per the next step, this is a single digit number. Sometimes you may get 2-digit number as well. So when this is a single digit number, what we are going to do, we are going to multiply this digit, this 9, with the oscillator. So 9 2s are 18. Whatever number comes, we add that to the 9. So here 18 plus 9 will give you 27. Now here we have got 27. It is a 2-digit number. So to oscillate this, we will follow this step. First we oscillate 27. To oscillate 27, we will take 7, multiply it by 2, 14. 14 plus 2 is 16, plus 3, 19. So your final result is 19. Your final result is 19. Now what we are going to do, we will check whether this final result, it should be either 0 or multiple of 19. This is multiple of 19. This can be divided by 19. So the given number 3971 will also be divisible by 19. This is the whole process. If you don't get any step here, you can just read these steps and again you see this work so that you will understand how we will go about it. We will go for the next example. For example, now we have to check if 92984 is divisible by 17. So first thing what you need to do is find the oscillator of divisor 17. So oscillator of 17 is 12. How? So first of all, we will multiply this 17 by 7. 17 7s are 119. So now this number ends in 9 and this is 11. 11 plus 1 will give you 12. So this way we have found out the oscillator of 17. Now we will follow the second step. So to do that, I will write, first of all, I will write those digits here. So 9, 2, 9, 8 and 4. This was our number. So we multiplied this 4 by 12. 12 4s are 48. 48 plus 8 will give you 56. So here you will write 56. It is a 2-digit number, so you oscillate this. So 6 will be multiplied with 12 and 12 6 are 72. 72 plus 5 will give you 77. 77 plus 9 will give you 86. It is again a 2-digit number, so we will oscillate this once again. So 6 multiplied with 12 will give you 72. 72 plus 8 is 80. Plus 2 will give you 82. So here you got 82. We need to oscillate this once again. So 2 will be multiplied with 12. 2 will be multiplied with 12. 12 2s are 24. 24 plus 8 is 32. 32 plus 9 is 41. So this is your final result. After oscillation, this is your final result. Now, is 41 divisible by 17? No, it is not divisible by 17. So, final oscillation result is not divisible by 17. So, the given number 92984 will not be divisible by 17. Now, let's see when divisor ends in 1. In this case, we get a negative oscillator. Before starting, I want to tell you that you have to be very careful about sign in this case. So we have to check if 75547 is divisible by 31. So first step, we need to calculate its oscillator. So oscillator is going to be -3 because 31 ends in 1. We drop this 1, this number 3, and its negative is going to be our oscillator. Then the steps which we had followed previously, we will follow the same steps considering the sign. So to start with, I will write the number. Our number was 7, 5, 5, 4 and 7. This was our number. So first we will multiply 7 by -3. 7 multiplied with -3. So it gives you -21. -21 will be added to this 4. When -21 will be added to this 4, you get result as -17. Now we need to oscillate this once again as it is a 2-digit number. To oscillate this, first of all, you need to understand both these digits 1 and 7, both of them are negative. So we will multiply -7 with -3. So when we multiply this, we get 21 as a result. This is positive 21. Be careful. This is positive 21. So this 21 will be added to this -1. As I told you, this is also a negative number. So 21 minus 1 will give you 20. And this is positive. So 20 plus 5 will give you 25. Be careful about the signs here. Please repeat the video if you didn't get the concept. Be careful about the signs here. Now here the number is again 2-digit number. So we will again oscillate this. Now this 5 will be multiplied with -3. 5 multiplied with -3. So it is -15. So -15 plus 2 is -13 plus 5 is -8. Now it is a 1-digit number. So we'll simply multiply this -8 with -3. So our result is 24, which is a positive number. 24 plus 7, it will give you 31. 24 plus 7 is 31. So this is your final result. So the final result is 31, which is divisible by our divisor 31. Therefore, the given number is going to be divisible by 31. One more example. Check if 92984 is divisible by 17. If you observe, it is the same question which we have done previously when the divisor ends in 9. Suppose we want to end divisor in 1, how we can go about the method? So first compute oscillator of the number. So oscillator of 17 is minus 5. How? 17 times 3 is 51. We drop 1 and this 5. Negative of this number is going to be your oscillator. Now we have to oscillate. So to oscillate it, first of all we will write number. The number is 9, 2, 9, 8 and 4. So first we multiply this 4 with minus 5. 4 multiplied with minus 5. It gives you minus 20. Minus 20 plus 8 will give you minus 12. So now this is 2-digit number, and I told you these 2 digits separately will be considered as negative digits. So to oscillate this, what we'll do, we will multiply minus 2 with minus 5, which gives you 10. So here 10 minus 1 is 9. 9 plus 9, it is positive 9 because this is plus 10. Minus 1 will give you 9. Plus 9 will give you 18. Now we need to oscillate this once again. So 8 multiply with minus 5. So you get minus 40. So it is minus 40. Minus 40 plus 1 will give you minus 39. Minus 39 plus 2 will give you minus 37. So here you get minus 37. Now both the digits will be considered as negative. Now minus 37, to oscillate this, minus 7 will be multiplied with minus 5, which is oscillator. So you get 35. 35 positive. Minus 3 will give you 32. 32 plus 9 will give you 41 here. So your final result after oscillation is 41. Is 41 divisible by 17? No, it is not. So the given number is not divisible by 17. So this is all about the divisibility by prime numbers. I have written all the rules in detail, which you can go through again. If you find it difficult to understand, go through it again and again. Just practice about it, and in short I have written the summary. So first what you need to do, you have to compute oscillator with the help of divisor, then oscillate the given dividend, and then finally check whether the final result after oscillation is divisible by divisor or not. On that basis you determine whether the given number will be divisible by a prime number or not. You can apply this method to test divisibility by any prime numbers. I hope you have understood the concept well, but still if you have any queries or ideas that you would like us to present, please leave the comment below. Check out our other videos as well. Thank you so much for watching, and if you like it, please don't forget to subscribe.